Today's lesson is 4-5 on proving triangles congruent. It's going to be quite similar to the last one we did, but this time we have two new shortcuts that we can use to prove triangles are congruent to each other. The first one is called the ASA Postulate, and the A stands for angle and the S stands for side, so this is the angle side angle postulate. If two angles and the included side, so the included side is the one that connects those two angles, of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So we're going to look at how we can use this to figure out, to prove that triangles are congruent. We're going to do this second one over here, and I'm going to write a two-column proof as usual, and it says, given that segment CD bisects segment AE, segment AB is parallel to segment CD, and angle E is congruent to angle BCA, prove that triangle ABC is congruent to triangle CDE. So I'm going to start with my little T-chart. Statements on the left, reasons on the right. And my first statement always comes from my given information. So they give me that CD bisects AE. Segment AB is parallel to segment CD, and angle E is congruent to angle BCA. I know all of this because it was given in the problem. So now let's see what we can figure out from here. If CD, that's this line segment here, bisects segment AE, oops, I forgot the bar on the top of that. That means that it cut segment AE in half. It cut it into two equal pieces. So your segment from A to C will be congruent to your segment from C to E. So I can put AC is congruent to CE, and the reason that I know that's true is because of the definition of bisect. Okay, now the second statement here says side AB, which is this one over here, is parallel to side CD. That's what these little arrows mean that you see on the picture. They've marked them parallel. So if you look here, this line is parallel to this line. And you have the bottom of these triangles, AE, this is a transversal that cuts both of those parallel lines. And then this angle A would have to be congruent to this angle DCE because they are called corresponding angles because of the relationship with the parallel lines cut by the transversal. And that's something that we learned at the beginning of Unit 3 earlier this semester. So we'll say angle A is congruent to angle DCE, and that's because corresponding angles are congruent. Okay? Now, we also had given at the beginning angle E is congruent to angle BCA. BCA is this one down here. So notice that we now have two angles and a side in between those two angles that's congruent in both triangles. That is now enough information to say that the two triangles are congruent. So we can use the last statement of our proof as the prove statement that we usually see. Triangle ABC is congruent to triangle CDE, and the reason is because of our new postulate, angle side angle postulate, We have two angles and a side in between that are congruent on both triangles. So angle, side, angle is going to be the reason we use there. All right, there's another shortcut that we have on the back. Angle, angle, side theorem. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and a side of the second triangle, then the two triangles are congruent. And it says you now have 5 ways to show that two triangles are congruent. The definition of triangle congruence, which was your CPCTC, where you do every of the 3 sides is congruent to every 3 of the 3 sides of the other triangle, and all 3 angles are congruent to all 3 angles in the other triangle. So that's the most involved one. That's the one we did in lesson 4-3. Also, we have angle, side, angle, and angle, angle, side. Angle, angle, side's the new one we were just about to do. Side, 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 and side, angle, side from last time. So those are all the shortcuts. We won't be learning any more because there aren't any more. So we're going to go down here and do this proof on number 1. It says, write a 2-column proof, so I'll set it up. Statements and reasons. My first statement comes from the given information. As usual, segment BC is parallel to segment EF. Side AB is congruent to side DE, and angle C is congruent to angle F. All of that is given. In the picture, you can see segment BC is already marked parallel to segment EF with the arrows. Side AB, this left side of this top triangle, is congruent to side DE, this left side of the bottom triangle. And angle C is congruent to angle F. So we need to find another piece of these triangles that is the same. And again, the parallel lines are going to help us. We have a parallel line at BC with EF, and then we have this transversal line that comes down and crosses them both from A to E. And that means that the corresponding angles, upper right and upper right, on these respective parallel lines are congruent. So I'm going to say for my second statement in the proof, angle ABC is congruent to angle DEF. And that is because corresponding angles are congruent. And now I have 2 angles and a side not in between with 2 angles and a side not in between that are congruent, matching parts on these triangles. So I'm ready to state my proof statement, which is triangle ABC is congruent to triangle DEF. And the reason that I know this is true is because of angle, angle, side. 2 angles and a side that is not in between, angle, angle, side, are the same. And that makes the triangles congruent. Okay, so you get to practice some more, proving that triangles are congruent now that you have a couple more shortcuts that you can use. So good luck with your assignment, and if you have any questions or if you need any help, please do not hesitate to reach out and let me know. I am here for you. Have a great day. Bye-bye.